Hey y'all, it's Miss Luter again. I told you that I was going to post some of these helpful videos to help you through your spring break packet. So today I'm going to go through all of the linear equations and graphing worksheets of that spring break packet. They are all the worksheets that start with the lesson 3 point something at the top. I believe there's 4 of them, and majority of them have a coordinate plane and an equation on it. All right, so we're going to start with page 47. 47 is graphing linear equations. Linear equations always, as we know, make a straight line on the graph. Linear equations are also functions, so that for every one input, there is exactly one output. And you can demonstrate that given a linear equation like the one that they have here. Y equals x over 2 plus 1. So that every time you had an x value, you can plug that x value into that equation to solve for the y value. For instance, if I did 4, let's do 4 at the bottom. If I plug 4 in for x, then I'm going to start 4 divided by 2. 4 divided by 2, that equals 2. So I'm going to write 2 right there. And then 2 plus 1. 2 plus 1 equals 3. So when my x value was 4, my output, the y value, was 3. And then all of these are coordinate pairs. So I have my x value and my y value of a point written in the xy form that I can plot on the graph. So to plot that for 3, I go over to x is 4, up to y is 3, and I plot that point on the graph. Let's try number 1. All right, number 1 has the equation y equals x minus 3. Well, that's easy. So let's make it even easier, and let's make x values 1, 2, 3, or 4. Okay, let's plug in the x values into that function equation. So when x is 1, I've got 1 minus 3, and 1 minus 3 equals negative 2. Negative 2. When I plug in x is 1, the answer is y, and y is my output or my y value. So when x is 1, y is 2. And there's my first coordinate pair. Let's try when x is 2. Plug in the value x is 2. So I've got 2 minus 3. 2 minus 3 is negative 1. So when my x value is 2, my y value is negative 1. When x is 3, let's plug that in. 3 minus 3, that's easy. 0. When x is 3, y is 0. And then 4. Plug in that x value as in 4. 4 minus 3 equals 1. So when x is 4, the output value of y is 1. And like I said, these are all now just coordinate pairs written in that xy form. So let's do this first one. When x is 1, when x is 1, y is negative 2. So we go to x is 1 and we go down to negative 2. That is my first point. Then I have x is 2, y is negative 1. Go over to positive 2 on the x value and down to negative 1 on the y-axis. There's your point. When x is 3, y is 0. Going all the way over to x is 3, y is 0. And the last one, x is 4, y is 1. X is 4, y is 1. And then sometimes it is helpful to have a straight edge to just simply connect the dots. Ta-da! I've got a straight line. Straight line on my graph for my linear equation. All right, so key points for this exercise. Follow what the equation is telling you. Make sure your x values are simple values. 1, 2, 3, and 4 works out fine. If you don't want to pick 1, 2, 3, and 4, make sure at least you pick numbers that are on these graph. Don't pick 15 or 25 because that will not be a point value on this graph. I would stick with just 1, 2, 3, or 4. And then whenever you find your x values, plug them into the equation and solve for y. Always remember that this table is written in an order pair, x, y form. So I would find my x value first and then go up or down to y. Truly, you only need 2 points on that line in order to, or 2 points on that graph to connect those points and make a line. But remember, with linear equations, they go on forever. It is a straight line that goes on forever. Please make sure you continue your line. Don't just stop at 2 points. All right, graphing linear equations is done. If I did number 1 with you, you can do 2, 3, and 4 by yourself. Now we have graphing linear equations using slope. All right, remember I keep on telling you y equals mx plus b, always. Y equals mx plus b. That is always the format you will see linear equations written in. And every letter in that equation tells you something important. I have my y value, I have my m, and my m is always the slope. I have my x value, and I have my b. My b is always the y-intercept. So when I'm looking at an equation, I want to identify those 2 important points first. What is my y-intercept and what is my slope? As soon as I can find my y-intercept, that would be my starting point. Find the point where the line crosses the y-axis. So this is a positive 5, meaning when x is 0, y is positive 5, and I would plot my point there. And then find the slope. Because the slope is a negative 2, that means it is in the fraction form of negative 2 over 1, because slope is always rise over run. So from my y-intercept, I know I have to go down 2 because it's negative, and then over 1, over to the right 1 because it's positive. So from 5, we're going to count down 2, 1, 2, over 1. There's my point. Keep going. Count down 2, 1, 2, over 1. There's my another point. And if you have a straight edge, connect your line. Let's try it with this equation. For 1a, given the equation y equals 1/4 x plus 1. If I follow the steps that I just mentioned up here, my first step is always to identify the y-intercept. Always identify the b. My b is a positive 1, which tells me that my y-intercept is when x is 0, y is 1. X is 0, y is 1. I can plot my first point. And then my slope, oh, my bad, y'all couldn't see that. I like it over there better. Okay, my slope, for my slope is my m value, and the slope will always go with the x. So right here, my slope is 1/4. And remember that is written rise over run. So it's positive 1 going up 1, positive 4 going over 4. Rise over run. So let's count that out. We've got our first value, x is 0, y is 1. And from here, I have to count up 1 over 4. So from 1, I'm going to count up 1 over 1, 2, 3, 4. My second point falls on 4, 2. And if I really want to think about it, my y values increase by 1, and my x values increase by 4. So if this point is 4, 2, and my y values have to increase by 1, that 2 now becomes a 3. I count up 1, 2 becomes 3, and over 4. If I'm at 4 and I have to count over 4, then my x values are going to become 8. So let's try it. I go up 1, over 4. 1, 2, 3, 4. There's my third point. Third point is x is 8, y is 3. Now all I need is a straight edge and connect the dots. Remember, linear equations are continuous. They go on forever. Don't just stop in between 2 points. These go on forever. I can have any x value and any y value on that line. All right, so we took an equation written in a linear form, y equals mx plus b. We were able to plot those points from that equation onto a coordinate plane to create a linear line. So, first thing was to find the y-intercept. Y-intercept is my b value. So when I have a positive 1 here, that tells me that my y-intercept is going to be a positive 1. When x is 0, y is positive 1, and that allows me to find that point on the graph. When x is 0, y is positive 1. That is always your starting point, always. From there, I can follow my slope. My slope is written in my rise over run. So I go up 1 over 4. Here's a trick of the trade, or a helpful hint, helpful hint. Y equals negative x plus 2. Remember I told you there's always that ghost of math, the ghost of algebra. There is an invisible 1 right here. So when you find your y-intercept, remember, because there's that invisible 1 right here, then you are going down 1 over 1 for that slope. All right, if I did one with you, that was a very good example. I walked you through all of the steps. Remember, if you don't remember what I said, step 1, 2, 3, and 4 is all right here. If I was able to do 1, you should be able to do 2, 3, and 4. Moving on. Now we have graphing linear equations using slope. So here they're giving us a line on the graph and they want us to create the equation. They want us to write the equation. Remember, those equations are always in the y equals mx plus b form. So really, what we're trying to identify here is, what is the y-intercept? Where does the line cross the y-axis? If I can identify the y-intercept, I can identify my b in my equation. Then I need to mark 2 points on the line where they're exact locations on the graph. Nothing in between numbers on the graph, exact locations on the graph. For instance, I have exactly at 0, 2. I have exactly at 5, 4. See how they're exactly on a intersection, on a grid part of that graph? I don't want to use a point of the line that falls in the middle. That's not going to give me a definite number, and that's going to make it difficult. I need to find 2 points that lie exactly on that graph. For this equation, they use the point 5, 4 and 10, 6. Now here, they're asking you to calculate the slope by finding the change in y, which is simply subtracting the y values, and finding the change in x, subtracting the x values. In class, we talked about that as in y1 minus y2 over a fraction over x1 minus x2. So that just means that you had an xy value of 5, 4. Here's my xy value of 5, 4, and identified that point as 1. And then I have an xy value of 10, 6, and identified that point as y value 2, or I'm sorry, coordinate point 2. So now I had to take my x values and subtract them. So y1 is 4, y2 is 6. Oh, my bad. Here they're using the y-intercept. Oh, they made it easy. They are using the y-intercept 0, 2. That's this point right here. 0, 2. So they made it easy. So we have our y value is 4, and our y value for this point is 2. 4 minus 2 is 2. Now if I look at that first point, 5, 4, my x value is 5. And if I compare that to that second point that they used, the y-intercept, my x value is 0. Here I've got 5 minus 0. X1 minus x2. The x value from the first point minus the x value from the second point. 5 minus 0 is 5. So here, that's how they solved for the slope of this line. That was a lot. Whew, that was a lot. So, if you want to look a little easier, when you've identified 2 points on your line, make yourself a little triangle. In between the points on that line, we have to count up 2, 1, 2, and over 5. From here, we count 1, 2, 3, 4, 5. That is the exact same thing of what we just solved for the slope 2 over 5. So taking this information, you can use the y-intercept and the slope to write the equation in y equals mx plus b form. And that would be y equals the slope 2/5 x plus the y-intercept 2. There's our equation. And let's try it. Oop, there we go. Let's try it with this line. Taking a look at this line, my y-intercept is all the way up here. So when x is 0, y is 7. That's my y-intercept. That's going to be my b value. Positive 7 is going to be my b value. And then I have to find 2 points, 2 exact points on this graph to identify the slope. Here's an exact point. Here's an exact point. Here's an exact point. Here's an exact point. Ooh, this one's going to be easy. So my slope, starting with the y-intercept, here I have to go down 1 over 1. That means I am falling down 1, but I'm going over 1. And that fraction 1 over 1, being that I'm falling down 1 over 1, equals -1. So I have a slope of -1. In order to take this information to put it in the y equals mx plus b form, I have the equation y equals my slope, -1, but really 1 is a ghost in math, so we don't have to write it. And then my x value comes next, and then my y-intercept, my plus b. So my y-intercept is 7. My equation reads y equals -x plus 7. And I'm done. That was easy. Let's try this one. All right, first step, always, first things first, find the y-intercept. Where does my line start? My line starts at 0, 4. My y-intercept is 0, 4. That is going to be my b value in the equation y equals mx plus b. I know b is going to be 4. Then I have to find my slope. Let me find another point on the graph that is exactly on the grid. Here's one point that's exactly on the grid and another point that's exactly on the grid. Between these 2 points, I can count my rise of the run. If I start the y-intercept, I have to go up 1 over 2. I have to go up 1 over 2. I'm increasing my value by 1 and increasing my value by 2. So both of these numbers are positive, and I have a positive slope of 1/2. That's my m value in the equation, y equals mx plus b. All right, I have all the information I need to write that equation. Y equals m is my slope is 1/2, x plus b. B is my y-intercept of a positive 4. I've got my equation. All right, if I was able to do number 1, you were able to do number 2. Notice number 2, you have a falling line. That line is decreasing in value. My slope is going to be negative. And then number 2b, I have a increasing line. It is rising. My slope is going to be positive. Make sure your number for your slope is positive. And don't get tricky. The y-intercept of this line goes right through the origin. So technically, what number would that be? And do I have to include it in my equation? All right, moving on. Graphing linear equations using slope. Here, once again, they're simply giving us the slope and the y-intercept, and they want us to write an equation. They want us to write the equation in this form, y equals mx plus b. Do you see something constant between all of these worksheets? They are all linear equation. Everything is written in y equals mx plus b form. Remember, m is my slope, b is my y-intercept. M is my slope, B is my y-intercept. The notes are right there on the paper for you. So all you have to do is take the information given and put it in that y equals mx plus b form. So here I have a slope of 4/3. That's going to be my m. And a y-intercept of positive 3. That's going to be my b. Y equals m, but m is 4/3. X plus b, but b is 3. There you go. There's my equation. Let's try 1b. Slope is -2. -2 is my m. My y-intercept is 4. 4 is my b. Put it in the formula, y equals mx plus b. Y equals mx plus b. So we've got y equals m, but m is -2. -2x plus b, but b is 4. Ta-da! Got my equation. And so on and so forth. All right, 4 worksheets. I did the first couple of questions. You can do the last couple of questions. Remember, this packet is due by Friday. I hope this was helpful. See you later. Bye.